So horizontal shifts. Now we're going to have some function and what we're doing is we're changing the input before we apply the function. And so it looks like this, x minus c. Notice that it's x minus c. That's really important. Okay, so when c is greater than 0, it's going to move to the right. And when c is less than 0, it's going to move to the left. It's going to shift to the left. Now, remember though that it's x minus c. So if I have something like, g of x equals f of x minus 3, then that means that 3 is what c is. C is 3, right? And so it's great, so it's going to move to the right because, right, 3 units, because 3 is greater than 0, okay? All right. Let's get some examples here. So here we have our, I kind of kept using the same graph. Here we have this kind of different function, you know, we just have a picture for it. But we, and I picked 3. Huh. Okay, so we already talked about this, but it's going to move 3 units to the right because c is equal to 3. So shift it 3 to the right. Now, after we do one, maybe I can help it make a little more sense out of it. Okay, so if I want to take that point on the far left and shift it 3 units to the right, it winds up being right here. So what that means is, if I were to put in an x value of, in my original function, I'll talk about this a little bit more, in f of x, I have the point, so f of x, I have the point -7, comma, 2. Okay, that's an ordered pair. But in my g of x, if I want to have an input of -7 so I can match it to the output of 2, then I have to put in a -4. So then when I plug it in, I would have f of -4 minus 3, which would be f of -7, and we know that's 2. So that's why it's working that way. I don't know if you've ever thought about it or looked at it that way, but you could do that with each of the points. I'm not going to. I'm going to take the transformation approach and just move them, all the points, 3 to the right. But that's why it's working that way. You have to plug in a -4 to get an input of -7, and that's what's matching to that point that has an output of 2. Okay, so here we go back to shifting things. Oh my goodness, why did it move? Why did things move? All right, so we'll take this peak point and move it 3 to the right. And then we'll take that bottom point and move it 3 to the right. Kind of the top of the parabola looking thing. Move it 3. And then our last point, moving that over 3. And you could find the ordered pairs for all these points. And then we just have to try to draw it. Not a very good parabola, not a very good curve on that last part, but that's the idea. And then that would be g of x. All right, let's look at another example. And here we have our parabola. So this is f of x. I don't know why I didn't just put the equation. I could have done that. I could have said this equation is, you know, g of x, because I know what this function is. It's x squared. Well, it would look like this, x plus 2 squared. That's how it would look. So sometimes you're going to get the equations like that. I point that out just so you know what it looks like. But that would match to what we're talking about here. You're adding 2 to the input before you apply the function, which is the squaring function, okay? So that's what's going on here. To graph it, all these, my 2, I should say, my 2 is, it's a -2 is C, okay? So it's gonna go to the left, put those points over here, and then you can just plot those points kind of based on your origin moving, if you think of your origin moving 2 to the left. And then that would be my g of x. Okay? So those points are all moving to the left. 2 spots. All right.